Hello everyone. So let's welcome to part 2. Part 2 is VSEPR Theory. We have discussed about how a molecule forms geometry when it has no lone pair, right? But अभी हमें बात करनी है जब molecule के पास lone pair होंगे. So there will be several molecule types at position 2 or A is A central atom, B is noctile atom, and E is the lone pair. Okay? The number 1. See, we have seen that steric number in AB2 molecule was how many number of atoms were bonded there, right? In AB2, 2 atoms were bonded, so the steric number would be 2. In AB3, 3 atoms bonded, the steric number would be 3. ऐसे ही AB4 में 4 would be the steric number, AB5 में 5 would be the steric number, and AB6 में 6 would be the steric number. But now, what would be the steric number for AB2E1? See. The total number of bonded atoms and total number of lone pairs becomes steric. So for AB2, E1 molecule, 2 plus 1, 3 will be the steric. 2 plus 2, AB2, E2, 2 plus 2, 4 will be the steric. And so on we'll discuss, right? Now, let's jump to the topic. We are going to know that what's the molecule type, the arrangement for it, the geometry and shape. Remember what we have discussed? Geometry is when lone pair is included in the structure, and shape is when lone pair is not included. And we are going to do the examples. So let's start. For AB2E1, see, there will be bonded atoms and one lone pair included. So it would form like a structure like this: A, B, B, and having two. See, that would be the structure. For this, the geometry will be what? It would be the same A. There would be the distance of 120 degree, right? And it would be known as, this structure would be known as trigonal plane. Don't forget the part we are including the geometry here, right? We are including the lone pair here for the geometry. Now for the shape, see, we are going to neglect this part, right? But the B molecules are going to be stuck like that. So the shape for it would be bent. So the examples are O2, O3, sulfur dioxide, right? That's the prime example. Now for AB2, E2 molecule, see, steric number is 4. Whenever the steric number is 4, remember this very well. Whenever the steric number is 4, the geometry will be tetrahedral. Okay, how? One A, a lone pair, another lone pair, and this B coming forward, this B going backward, this A, these two lone pairs in the plane, right? Let me tell you the tetrahedral again. One on top, one at front. This will be sliced on. So क्या हो जाएगा? It will be divided in, and another one coming forward, another one going backward, like this. See. Like this. Okay. So that would create, it would form tetrahedral. The bond angle that would be 94.9. Okay. That would be formed tetrahedral. And the shape would be bed shape. Again, why? We are going to detect the shape, okay, and it will be forming a bed shape. The prime example is bottom one. See, the steric number is 2 plus 3, 5. Whenever the steric number is going to be 5, we can predict the geometry is trigonal biparallel. Right? We are going to arrange it. A. This 3 E's are going to be the maximum distance. So they are going to arrange it like this. Okay? And these two B's are going to be X-shaped, right? Perpendicular to A, right? We know this very well. The geometry is trigonal bipyramidal. And neglect these lone pairs. So the shape would be this, correct? So for example, we have xenon HCl. Right? This will be the example. Again, for AB3E1, the steric number is 4. As I told you here, whenever the steric number is 4, consider the molecule's geometry to be tetrahedral. Right? Arrange it like this. A bonded with 3 B's and 1 O. Right? Can you predict what the symmetry here? It is obviously tetrahedral. And if I ask you about the shape of it, so what you are going to do, what you are going to predict, the shape without the lone tube, that is, yes, it is trigonal pyramidal, right? It's going to pyramid. It's trigonal. The example for it would be, yes, ammonia. You'll be saying now that's your favorite, you're repeating it over and over. So yes, these are the 4 types. Let's start with AB3A. See the steric number for it. The steric number for it is 5. We know this already. For 5, the geometry would be trigonal bipyramid. We are going to draw A. See, these 2 E's would be going to arrange in the equatorial position. The position is known as equatorial, and these positions are known as axial, right? These are going to be arranged like this. Okay? Here, 2 B and B are going to be arranged, and here 2 rows are, right? This is obviously we know what kind of geometry it is. It is P, 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 trigonal bipyramidal. But with the shape, we are going to remove it, right? The shape is T shape. This is known as T shape. The example for it is PLF3, right? It's the for A before B1. The steric number is 4 plus 1, 5. For 5, the geometry is going to be, yes, TVP. Again, we are going to draw it. But consider one T is on, right? Only one E is there. We are going to put it here. Okay? And other B's are going to be axial and equatorial. Okay? Right. So, obviously, the geometry is TVP. For its shape, what we are going to remove this thing, and the shape will be like this. Okay, it's moving like a seesaw. We will give the name will be seesaw. Right? The prior example will be SF. Right? Now moving to the next one, that is AB5E1. It is 6. The steric number is 6. Whenever the steric number is 6, predict the geometry is going to be octahedral. Right? Draw the shape. A. 5 B are there. So how we are going to arrange it? We are going to arrange it in 4 B's in a plane. B, B, B and B in a plane. One E is there, another B at the bottom or top where we are going to place it, and a lower. Right? This is your octahedral geometry. What is it? What it is? It's called octahedral geometry. It's very clear. And we are going to remove the lone pair, right? So the shape for it is going to be, see, it's kind of square and a pyramid has been formed here. Like see, a pyramid can form upwards or downwards, but however you like it. But if I put it upward or downward, it's going to act like a pyramid. The name of the shape would be square pyramid. The prime example would be BRCL5. Right. Now for this molecule, AB4, E2. The steric number is 6. Again, the geometry is going to be right octahedral. Orbit A, and it's very easy. We are going to place our 4 B's in a square within a plane, and 2 lone pairs at top and bottom. Right? The geometry is, yes, octahedral. And obviously the shape for it is going to be, we are going to neglect it, right? And these 4 B's are in a plane. So it's in square shape and a plane. It is going to be square planar. The prime example is XCF. But also now talk about the bond angles between these two bonds, like lone pairs and our bond pairs. See, it has 120 right? It has 4.58 due to these 2 lone pairs, right? Otherwise, it would be having 29.5 degree. Now moving forward with HCl. See, these two are perpendicular on the plane, so it will be forming 90 degree. These three lone pair will be having a distance of 120 degree, right? And other than that, these two beams will be having a proper 180 degree, right? Bonding. Moving towards this one, it will be having 90 degree, right? Right here, same thing would happen. These two would be having 120 degree. These right would be having 120 degree. These are 90 degree perpendicular, and these two B's would be having 180 degree. Right? Similar case would happen here also. Now here in an octahedral geometry, what happens? These two would be having 180 degree. These four B's in the same thing would be having 90 degree, and this lone pair and this lone pair and this B are perpendicular to each other. Are perpendicular to the plane, so they will be forming 90. And similar case we'll be having in the next. That's it. See, this is a small thing that we have to remember. If the steric, in accordance to steric, like if the steric number is 2, then we are going to predict that the geometry for a compound is going to be D, right? If the steric number is 3, then we are going to predict that the geometry is going to be trigonal plane, right? If the steric number is 3, then is going to be what? Tetrahedral. Following up with this, the steric number is 5, that is going to be that is trigonal bipyramidal, and if it's 6, then it's going to be. See, the same goes for the hybridization only. For the hybridization, which we have talked about in the first period, that was for linear, it's going to be HP. For trigonal plane, it's going to be SP2. For it's going to be SP3 combination. For PPT, it's going to be what? SP3D, or S is also going to be DSP3. Right? For octahedral, it's going to be D2SP3 or else SP3. Right? These are going to be our hybridization for the topic. Right? Now, if we have to find a hybridization of any particular element, then how we are going to do it? We have a formula for it. That formula is the rule. The rule is known as m plus n. Right? What does this rule say? This rule states we have to add number of valence electrons. Total number of valence electrons. Obviously not of several atoms, of every atom over there. Okay, good. And we will divide it by 8. Right? Like for example, let's talk about SF6. Right? For SF6 molecule, what we are going to do? We are going to add the valence electron for sulfur, that is 6. For 6 chlorine, we know valence electron to the chlorine are 7. Add divide by 6. It's going to give us the total sum of 6 plus 42 upon 8 is going to give us 28. Right? Divided, it is going to be 6. That means the geometry is going to be octahedral for it, and the hybridization is sp3d2 or is d plus 15. That's it. Other than that, if we are going to talk about another compound, let's take an example of HCl4. Right? What's going to happen? We are going to add the valence electrons. For the non, it's 8. For fluorine, it's 4 into. For fluorine, it's 7. Right? Divide by 8. It's going to give us 8 plus 28 upon 8. That's going to give us a sum of 36 upon 8. 36 divided by 8 is going to give us 4 plus 4. Right? So, what we have now? This 4 is the fully bonded atom. Like, it's going to give us A, B, 4 molecule, and these 4 electrons, like 4 electrons are remaining, right? It's going to form only 2 molecules. right? So the structure would be AB4A2, right? And for AB4A2, it is 4 plus 2, pentahedral, or this is a pentahedral, geometry, the shape, and the hybridization would be similar, but we are going to find out that how many load pairs are also going to form, right? This is how we are going to calculate the geometry, hybridization, as well as for every molecule, right? That's it. Going to solve some questions of previous year NEET. See, first question is, so the following species has a bend shape according to Western. See, at first we know this very well, the carbon dioxide forms a bond like this and has zero load, right? It is ABD form. Similarly, SO2, it also has AB2 form, but remember this, sulfur has uh, six number of electrons in the valence and two electrons form load, right? AB2, E1. So the shape of SO2 is S will not O double one like this, right? It is the geometry is trigonal planar, but the shape is bell shape, right? Which we have solved already. So that's the correct answer. For BeCl2 it is linear and for BF it is trigonal planar with zero number of nodes, right? That's for now for the question, shape of XAF2 molecule which it is linear, bent, trigonal planar or tetrahedral. See, they are asking a shape, not the geometry, right? So what we are going to do, we are going to solve it for XAF. XEF2. The formula we are going to apply here is N plus N2. Right? What was the rule? The rule was add total number of valence electrons in the compound. For Hc it is 8. For chlorine it is 2 into 7 divided by 8. Right? We have got the formula here. 8 plus 40 upon 8 is going to give us 22 upon 8, which is going to be equal to 2 whole 6 upon 8. Right? H, what kind of molecule? A, B, 2, E. 6, that means how many will we have? 3, right? It would be 2 plus 3, that is going to be 5. It is trigonal pyramidal. How are we going to form it? There are 3 lone pairs, right? Remember how we are going to form it? A, 3 lone pairs and 2 bonded atoms. Like this. So, the geometry is going to be what like this? Sorry, geometry is going to be PVP and shape is going to be linear shape. So the shape is that. Next, calculate number of lone pairs in geometry of ClF3. What we are going to talk about? ClF3. See, for ClF3 we are going to do same thing. What? For chlorine we have 7 number of valence electrons. For 3 fluorine we have 7 number of electrons. Okay, by 8, that's going to give us 7 plus 21 upon 8 is going to give us 28 upon 8. When we divide it, it's going to give us 3 plus 3 whole 4 upon 8. Right? That means the structure would be AB3E. How many lone pairs are going to form? 2. Right? One lone pair equals to 2 electrons. 4 electrons are there. That means 2 lone pairs. And 3 plus 2 is going to be 5. 5 is what? Your steric number. We know for steric number 5, the geometry is what? Geometry is PVP. And the lone pair, number of lone pair is 2. They have asked us. Calculate the number of lone pair and geometry of central atom. See, they are talking about the number of lone pairs. Number of lone pairs 2. Either this one, either this two. This will be our answer. But see, I guess there's a misprint in the question. They have not asked the geometry, it's shape. Right? The geometry is CBD, but for the shape, it is what? It's drawing. Number of electrons are there now. 2 lone pairs are there. So, Cl, F, F, and F. Can you get the shape? It is C shape, right? Triangle. That. So for the fourth one, they're asking us the square mirror shape, right? We should know what square mirror is. The square over here, A, and the four corners, there is a B molecule. This is square mirror. Obviously, they have two rows at the top. Right? Let's take example of HCl4. From let's take it as from P and 5. Right? Phosphorus has 5 number of valence electron into 7 into 5 upon 8, right? It's going to give us 5 plus 35 upon 8, that is 40 upon 8. It's going to give us 5. That means 0 number of lone pairs, right? And it's going to form AB5 type, right? Next, SL6. Sulfur has 6 number of valence electron and 6 into 7. 7 for the valence electrons of fluorine. Divided by 8 is going to give us 6. Sorry, 6 plus 48 by 8. That's going to give us 6. That's going to be these AB6B. For BF3, it's going to give us for boron. Boron has 3 number of valence electrons and fluorine has 7. 3 plus 21 upon 8 is going to give us 24 by 8. That means it's going to give us 3. So AB3 type it is. But we want two lone pairs over here, right? For square plane. Now let's jump up to HCl4. For HCl4, number of valence electron in HCl is 8. For fluorine, it is 4 into 7 upon 8. It's going to give us 8 plus 28 upon 8. Obviously, that's going to be 36 upon 8. And obviously, 8 fours are 32 plus 4 upon 8. That means going to form AB4 P1 2 because 4 electrons are remaining, right? That means it's going to give us square probability and answer is XA. That's it. So I hope you know. Thank you.